Did you guys have a break? Did you stretch? Okay. So this is the last lecture, 10th lecture, and afternoon we will have one tutorial which I want to focus on the pollutant of concern. What's the focus in addition to BOD? That we will do. We will see a case study how it has been successfully implemented and how it is done already. It is working. And also I want to show you a video on that how it is implemented on the site. So we will not take one, that's only 1 hour is given, we will end that. So we will put everything together within an hour. So this is the 10th one, last one, economic approach to small and medium wastewater treatment plant. And we have seen earlier the little bit here and there the economics is also a very important part. We focus on the quality that is there, but economics is equally important. And here we will touch some of the areas where we can stretch a little bit and try to understand more about that, what it means. Of course, there is a with the due focus on without compromising the water quality, right? That is your first focus. Then the economics, right? And you also seen all these previous lectures. What should be your focus? How the water quality is protected, and how you can have the safe environment protecting water and the soil. So that is our main focus. That is the ultimate, and make sure that that is we are all working towards that and going back and fixing the things. So that is was our focus in this whole lecture series, and you should focus on that. So let us see economic management of industrial and municipal wastewater treatment. So reduce the cost and increase efficiency of a wastewater treatment plant to provide a reliable treated water supply. What it means? It means we always, when we say the economic saving of the money or saving of the funds invested for that. So industries, land application, agriculture and public utilities. So land application, how you can save money? Because if you are using the every byproduct generated from the wastewater treatment plant, then you can save, you can think of money. I have given you earlier some of the examples, and also in the tutorial we have seen how earlier they were operating, and then how slightly they moved away towards recycle, reuse, right? That way you can save a lot of money. I have also given examples of here how they did, how we did, right? It is possible. It is not that it is not possible here, it is not possible there. It is not like that. It is just an approach how we do this, how much is it's important, how we focus. So now that is the greatest trend. What we are doing is not we are just treating and discharging, but we want to go a step further to make use of that treated water, treated wastewater for a very important purpose. Today, water is, that means water sources are reducing. We have seen everywhere. Even in other countries also there, where we see uh, a lot of resources were there one time, it is reducing. So that is why it is important when you are using a large amount of water for the industry, we make sure that this water, treated water, is used properly. Is it? If you are not using for any the land application, you are at least using it for replenishing of the groundwater. We saw one example on replenishing. where the city after the treatment wants to recharge the groundwater. You have to do you nowadays we do their rain harvesting and on very small quantity, but similarly in a larger scale we can do for the industry. That is how you can save a lot of money, right? You also seen instead of using a treated water or the river water can be used for the drinking. That is your first priority, right? So then this water, treated water, can be used for a land uptake, right? So that is what we are doing. The one example which I am going to give you, that water is also used for land applications, growing crops, right? So that is how if you use it for multiple purposes, then there is a savings. Public utilities where you are using. Industries also use save money. How? By recycle. I have given you one example. We haven't mentioned that as a case study. Then down the road, sometimes 2 years later, we will find how we can do recycle similar way like that. But currently, I gave you an example of Microsoft where it was discharging it to a wastewater treatment plant. Then they go complete loop, no water usage. For their air conditions, they were using the recycled water continuously. When the concentration reaches to higher level, then they used to use. So this is how it is possible. Industry, land application, and public utility. What is public utility? How you can say what is the relation between economics and use of treated water for the public utilities? So you have a large parks, public places, applying water to the big gardens, stadiums, everywhere. So you don't need any river water to do that, right? If little suspended solids are there, not contaminated, you can use that one. So that is how we have three sources, three examples I gave you here. Industry also can do recycling, closed loop. By that, they can save a lot of money. Number one, right? You have seen many. And land application and agriculture. I have given you an example and we saw the tutorial how it is done, and also we'll see another example, and now that is widely accepted, right? So that way if you do, then economics changes, right? You that water it can be used for a drinking and this water can be used for a, how important it is. We have an example where the treated water was left to the irrigation canals also. So that means that much precise it should be. It should be contaminated. That is why you have to go. I was all the time I was emphasizing on one factor, the pollutant of concern. If it is there, then you cannot. There are situations they were doing it, then they found that, and then they did not accept it. So whole your then they don't stop, they have to go back and then do a additional treatment and put efforts for that, and then that is what happened. So there are three examples how which depends upon the economic value, cost savings, reduce water consumption. That is important. And reduce energy usage and maintenance cost, that you have seen many examples. I have heard a little bit earlier also how we can do the energy management, right? So because aeration is the big cost, that is why we are slowly moving for different technologies where you don't need an aeration, right? But it depends upon the other factors. If it is an industrial wastewater high BOD, what you will do? You cannot apply it cannot be treated aerobically. What we do anaerobic treatment, then the supernatant is collected, and then we give an aerobic treatment. So that is how we do a combination. Is it? Then also see, when there is an organic waste produced, food waste from food industries, and also many I will give you another example which we did when I was here. So what we do, we'll send all that food waste to a digester and would produce an methane. We did that in IIT Bombay. We did that. We used to analyze when I was there. So there were many hostels, 10, 12, see big food waste, right? So here also it is there. We collected that. We used to go to the digester and collected the digester and our treatment. Then methane is to be, but you have to analyze that methane whether it has a calorific value. If it is less, it's okay. You can add a propane and make it compatible. So that way you can mixing, you can reduce the cost. So that we were using it for the whole canteen is was running based on that. So that is how you can save money also. But once for all system, right? But initially you have to take steps because these kind of in the villages and all they are doing it. I've seen many places, but they need a lot of maintenance. They have to be done in a large scale. If it is a small case, people today you are doing, and 8 days you are going away, not doing, so it doesn't work. So that is why in the larger scale, when you are doing in a digester and the if you are taking out the fuel out of it, then there is a system. So reduce energy says maintenance cost that. So reuse of wastewater we have many times, right? Use byproduct. We also talked about the byproduct like sludge which is generated free from the metals, contaminant is a manual. Sorry, that's the cost. I'm giving you the various venues how you can reduce the cost, right? That will be an additional revenue for running the wastewater treatment plant. You should think economics, right? Now we are our focus is on the economics, right? uh, Considering that water quality is there first, right? Use of byproduct biogas can be used for agriculture and energy generation, that you are saying, right? So we also nowadays there is a trend. In earlier we used to do the waste which is generated, agriculture waste, just like that people used to burn, right? Now there are many steps have been taken to generate the fuel out of that. So, what was the main issue there? Why earlier it was not happening? Earlier it was not happening because if there are certain lands there, who will collect that and take it to other place? If you are having a big plant at certain place, they used to earlier say you have to bring your waste. Now people are lazy, they don't bother. So hey, taking this stuff from here to there is this much cost. They do economics. So they just used to burn. So what used to happen? That you people who are around here in Delhi and all around, how that used to take. They used to just burn. What they are doing? They are wasting that resource and also creating air pollution. If you are not contributing good to the system, it is okay. No, you not to do a good, but don't contribute bad to the system. So that was happening. So now, with years of experience, taking some actions on that, moving one step forward, somebody has to move forward. So then they said, you don't bother about bringing the stuff there. We will come and take. So then the ball started rolling. Ultimately they are people who can go and collect and bring the stuff. And so that is how you have to change your policies to do the economic byproduct is very important in case in almost all the fields, which is very important, and give an additional revenue, generate an additional revenue. Some industries can generate revenue by selling treated wastewater to other businesses. That is how your system. Also the kind of I told you earlier, some of the companies they collect waste and dispose it. That means what? That means they are selling. If it has a value, they sell. If it is a contaminant, they pay, right? Oil and grease, they may pay money because they go and recover product. I have one facility there, their job they had started recently. One was down in California and other places. Recently in Washington, they collect this oil and grease from different industries, from houses, restaurant, and they create a byproduct. Their entire plant is run without energy. Energy is generated there itself, and they sell the products out of generated out of the treatment system. So reduce energy usage, maintenance cost, consistently upgrade. You can't put the old pump and expect that the efficiencies are. Now new pumps are coming up where the big energies, the saviors are there. How you do? People go for solar, people go for other sources of energy in order to make it more economic. Recognize the common operator ever. We have dealt with that already. Reduce the aeration to achieve the energy. We have seen when to start, when to stop, how the aeration can be done depending on understanding of the organic loading and hydraulics. So reduce aeration, that we have already seen on that, to understand the biological process better. That is important. These all we have seen, how the organic compounds are degraded. That is all we have seen, when to start, when to stop the aerations, right? We'll go faster, additional. Minimize the quantity of solid produce, that is important. Denitrification, phosphorus removal, and the successful process performance judged by effluent quality, that is also important. Why that quality you have to judge is important? Because based on the quality, you can also decide the economic value of that, where this can be used, right? If you want to use as a cooling tower water, you don't need as clean as our drinking water, right? You don't need as clean as an even river water. So that is why we assess, we make understand. So what happens? That is why the earlier slide you see, some people sell wastewater. Is it? If they feel that it is a burden, they cannot take a use. There are people who can, find a ways to make enough money out of that wastewater. So that is what it is. And growth reaction, energy reactions, that we have covered earlier with a different perspective. Now here the growth reaction, organic nutrients and biomass, that also we have seen before, and this is important. Analysis is important. As you go how the system works efficiently, then you have to analyze what is the sludge produced, how much volume it is taken. So for example, why this is important? So we are stretching it little bit. Earlier you say you measurement was your focus. Earlier your focus was measurement. Measurement how much quantity is produced, sludge. That was your focus. But I'm going to stretch this to the further. If the sludge is produced in a big ponds for food industry, what happens? Your one-third volume is covered already by sludge. So your volume is reduced. How it is going to be economical? So that is why your frequency continuous removal of sludge is required. This is economics. Earlier we saw you have to remove sludge. We stopped there. But when you become more expert, you stretch yourself. It has another effect also. Now you think, if you ask anyone, any person, they said you have to remove sludge. But if you ask it, see in the economic perspective, you are still in loss. You are removing, but you are keeping it there only for a larger time. So your volume is reduced. Instead of 2 pounds, 3 pounds, you need 4 pounds. 1 pound, 3 pounds. So economic value. This is how you have to start thinking in the beginning. How what these products, whether you can make the product out of the waste, how it is going to affect. If you think in one direction in the form of just removal, it is done, right? So you have seen this reaction, generic reaction, where the treatment done. This is also the same way in terms of the oxygen requirement, right? As the organic compound reduces, that's why the aeration volume reduces. You have to think smartly. How you will find out whether aeration this much is required or not? You will see the loading and then you can do it. So these are you have seen this. This is the generic wastewater. So regulatory data, we have seen how to analyze this. This is the normal values of the activity sludge process. Then you see the process control data, they are intact. Because when you are discharging the effluent, if you are not maintaining the temperature, if you are just discharging, it is causes. So otherwise what happens? It is possible to search for a neutralization within the process plant. Whether is it possible to mix it? We have seen many industries like that. Earlier, they used to discharge wastewater with the temperature. Then they reviewed the process. They say that within the process they can reduce the temperature and discharge. So your major treatment is gone there. You are reducing the bigger value. Now we are seeing it in the perspective of economics. Earlier what we were thinking, you have to reduce the temperature, build a equalization tank, keep it until the temperature goes down and then discharge. But here what you did, you went back. You are reducing the temperature within the process plant and you don't need any equalization. Right? That is the smart thing. So thicknesses I have already mentioned about the blanket thickness and all, how it will the volume of the entire pond is reduced, and instead of one pond you need two ponds, right? So more process control data, you have to think critically how these affect, how we can vary the flow rates, pH. You should see what are the different stream coming from different processes. If an industry is there, if the industry is there, there are different streams coming in. That is how the water is collected. We did this in the food industries and all. So wherever the temperature is high, you can mix it inside the process and that make it normal. Then you don't need. But earlier focus was to measure pH, then treat. See what you did, you spend double the cost. This is the economics we are going back to. So that's why, since you are many people are on the yeah, some people are on the economic side also, but as a researcher you should also know how you do optimization of the process. Many people study, right? So that is how you have to do, because you are thinking angle changes here. You are not thinking like a just a person who is working there, right? So, and you need a proper equipment also. Then you know about these values, we already talked much about this one, and the aeration tank effluent profile. You know the how, why this is, there are this is one factor. You think in a different way now, which is efficient, you will have to find out first. Because of the economics we go a little one step ahead. Earlier we see whether we are able to maintain the oxygen concentration or not. But now we are thinking one step ahead. We are thinking which is efficient. You can reduce a lot of money there, right? So that way you have to think. So this is a bacterial growth. This is has a very important in the biological process. That is why your all other parameters are important to take care, so that your biological process is in the process. So that is greater emphasis on that. Continuous measurements, analysis, why efficiency is reducing, whether the any contaminants is existing in the sludge because you are recycling the sludge. So that is why your first question as a researcher, you have to see whether it is treating or it is going through the sludge. That is why you do a sludge analysis, you do a scan electronic microscope, what kind of bacteria are there, right? So that we are thinking one step ahead about. Then if what happens, I put this slide specifically, there is a common understanding that in case of the domestic wastewater we have a heterogeneous bacteria, they are taking place. But I have also told you one example how you can acclimatize this bacteria to remove particular pollutant. Is it? We have isolated. See, when I was working on the particular wastewater coming from the refinery, which has toxicants in addition to BOD, what we did, we trained the bacteria from the heterogeneous to consume cyanide, right? One of the contaminant, one of the other contaminant TC. We try to train that bacteria. Is it? We ultimately we compel that is it trades to remove that. So that is possible. But how it is related here in the domestic wastewater? If a contaminant is flowing in addition to your BODA, what happens? That there are bacteria. It will start affecting in both the way, because it will start destroying this bacteria, the which are the toxicity will destroy the domestic bacteria. That is how efficiency starts going down. And there may be, depending upon the concentration of the TC, it may be training the bacteria to remove other components. So that is why there is an imbalance if you don't know what components are present in the influencer. So that is, and measurement is always there. You have to update, you have to understand, make sure that in order to have an economic value. If you take a wrong value, then you have to go for a re-evaluation, violation, and you said that system is not working, you will appoint people, is it? Then they will find out, because then they will understand, go back, the data is wrong. The people, consultants who come there, they will not tell you that the data is wrong. So we fix the problem. So that is why the people working there should be much smarter than. So clarifier problems, these are the problems which started giving multiple problems. Then you have to spend a lot of money. That it will affect entirely the economics of that. So we are seeing this in the perspective of economics. You know these numbers, how it will give a little guidance how it should be. If it is going apart, then you should start thinking in a different direction, whether is it at the base level or something different is happening, right? This we have seen, this is also seen, and this is the, you will have to observe all the time the biomass, the health. Then before the complete damage occurs, then you should be able to do something to fix it in the big initial stage. Otherwise, when everything goes on, if the treatment plant is not working, then what happens? You will have to do a bypass. You can't even do a recycle, because the plant is not working, and until there is a recuperation, you have to do bypass, you have to leave it somewhere. So you cannot leave it somewhere. Yeah, you can do it, but what you want to do, you need a big tank to be constructed so that you can store. In such cases, there is always an issue or problem you have in some storage extra. But if it is happening often, what you will do, you will have to have a series of tanks to fill that up until it is fixed. So economic just destroys there. I have seen these kind of situations have occurred many times. Then the measurements, I have talked about that, how accurate it should be there, how representative it should be, that we have seen, and the keeping the parameters intact to make sure that things are going as it is designed, right? Then there are some issues with microorganisms. Always you will have to careful. That is why we see people with the biological background, chemistry background everywhere. They can find out what is going on there. They are expert, they develop later, have a much understanding about the chemicals, how they work, biology works. So they are also a big important component of this system. Environmental engineers, environmentalists, or people with that background, they will do and help us. Set. And regarding the equipment, you should have an updated equipment that will reduce a lot of your headaches. If you have an amount in today's conditions, you need not to collect the sample, go away for analysis in some other place. There are some time value, the transportation, that is all big cost. You have any handy advanced equipment, so that will reduce a lot of your cost. So we are thinking, we are screening where you can save money. It happens when there is a big lawsuit, people will say industry, see, find out, come with the ideas where you can reduce. Where you can reduce, otherwise you will have to go out. So then people start thinking. So this is how. So you have already seen the approximate value of reduction when you change the DO. Problems with high recirculation of the sludge. You will have to see if you are, too much sludge is coming up, and if it is not active, because if the bacterial health, if the secondary containment is not working properly, what you are doing, you are recirculating that again, so it will destroy, means more maintenance cost. So that is how. Problems with the overlooking influent loading variation is important. You have to make sure that, why, see, you are thinking in a slightly different way. How you are thinking now, earlier overloading should not be there, that was your stop there. Now you are going little bit further, you will see what is the concentration of MLSS and MLVSS. At the oxidation pond, what is the bacterial growth? Accordingly, you are controlling the organic loading and hydraulic loading. That is important. If you don't have that understanding, you will just fall. So we are thinking one step ahead. These are the problems. How you say that the field and design doesn't work if you don't have that understanding, though, then it becomes difficult. Difficult in the sense more money you have to spend. You have to bring a smarter people to fix that. Right? So this is, we have talked about the aeration ratio loadings on earlier, and also problems with not analyzing the process data correctly. I have told you many research people are there. That is why I emphasize, several times, you should make sure that your data are correct. Right? Always make sure, do review paper, see why, under what circumstances, what is the criteria, what value the data has. Otherwise, what happened? You are building a structure which has a very weak foundations. Then, when you build everything, then you will come to know this data is wrong. Right? As much as data. Seasonal variation we take a variation at the time of the organic loading, variation with the different hydraulic loading, all the combinations you will do. Right? Yearly variation, hourly variation, you will all study that. Then there is a consistent trend you will see. That is why when people submit the report, I say, did you do the trend analysis? I introduce them. Take data and submit it. What is that? Did you do the trend analysis? Then you will start understanding. Today, this month it is coming this way it is. Then you will start thinking. So that we have included as a part of their report. When their report, it should be a meaningful. Don't be a big report, nobody reads like that, not like that. Then we have gone, I want to tell little bit more about this reporting. even though we are talking of the economics. We have arriving to a system. I was mentioning earlier the major components like industry and three layer of regulation, state, federal, and the industry and other public also, or the other stakeholders who are responsible. We are developing an electronic commerce system where the people and the industry and the regulator, local people, local regulation, all they can see data at a time, right? On data. So when the industry submits the data, they can do online, and other all the regulators and other the responsible people can see. That is the new introduction coming up in the implemented in one city, big city successfully. It is going on. Then there is a deadline. We can extend it to other places. That is the latest one where everybody can see, right? Nothing is wrong. Huh? That is the latest. So if you what they are doing is if you are able to see here only, that will be great. You can everybody start analyzing. So there is nothing is wrong, right? Anybody can see. So this is we are heading towards that. So failures, we have talked about that lot about the failures. Then you should know about your plant. What we have already discussed so much. You should do a trend analysis, understand what is the relation between the flow and other parameters, how it changes. Right, this we have already talked. What should be the due concentration before, and reduce aeration, save energy. We have already discussed. Aviation and the cost, they go hand in hand, and we should be smart enough to reduce. Reduce aeration, save energy. That is what I was all the time telling. The aeration is the important factor in order to make it more economic. But what is the alternative? We are going towards a treatment where you don't need the aeration setup, right? I have shown you one example, and we will also see today. Reduce aeration, save energy. That's why that is the trend now. What are the two latest trend right now we are going towards? One is go away from the radiation, reduce lot of energy, and another is reuse, recycle, reclamation, water reclamation. So that is the is it. This we have already seen. Nutrient discharge, reduce aviation, nutrient discharge, and the different oxidation reaches, and the oxygen concentration. We have already talked about that. Before and after, we have to one particular example so that you can have an understanding. We already discussed about it, right? Other benefit, turning aeration ox. Again, the sludge settleability may improve, eliminating filamentous bacteria, and alkalinity will be generated. But when you stop aeration, there is another consequence also. The settleability and the type of bacteria that will cause a little harm. So that is why we have to have a very balanced. It is really tough to stop it. You can keep it low, but completely stopping may cause a problem. Is it? If all the sludge settles down, it may create enormous conditions, and very your purpose of treatment is not so. That is also there. Okay. So questions? Any questions in this last lecture? What we learned? We learned little different things related to the economics. If you want to run the treatment plant economically, then you should know without compromising the quality where you will reduce. But that is possible if you know very well where you can cut the cost. You know the byproducts should be used. I can understand that. All the byproducts must be used and made money, you can reduce. That is very common understanding. But I have given you different understanding about that. If you don't maintain the ratio, if it is a sludge accumulation at the bottom, if your TSS is not removed properly, what happens? Constructing a big new pond. See, your thinking is slightly different. So these are the things we have studied. I think since a lot of participants are on a research background and also many of them are professors teaching their students and people who are working in the plant chemistry background people, there is a lot of message in there. I want you to think in that direction. If you think in direction, same you can send, educate other people also. When we talk about the treatment plant, so different group has a different message because they have a different expertise. Research people who are doing, they can think about the generation of the data, how it is, how can be, how reliable, how representative your data, because you will be working more on the people with the chemistry background and all. You should always, when you see the treatment plant, just don't think BOD is reduced. You think further about the priority pollutants and pollutant of concern, how they can affect. That must be your angle, how you see. We change the angle now. As we come at the end, you become more expert. You don't think just in the beginning how it should be. I have told you also, we made in a couple visits here what question you did not ask. Now that makes sense to you. Is that right? If I say why you did not ask that question, do you feel that that is right? I could have asked that question. Now, if you feel now, then it is successful. I can see. That is why when you say you have a lot of questions just for you, I don't say that you should create a situation where you are, but you should ask that question. That the how you ask that question to them, then they will understand. They know much better than you. Is it? If you don't ask that question, what happens? This is our authorization, we are doing this. There is a river, but no water, that is the authorization we are discharging. So that is why your thinking angle is, we are extending and you should become much smarter and smarter as you learn. You can learn more further on that. But if you know, then you can ask. That is why it is important to understand, because as a designer, as a monitoring all this stuff, I know where the things are going. Because that is what we say. If there are many questions for the consultant also. When they decide, no, that is not right. When you can say, when you know that. So that is why that is important. If this side is much smarter, then you can. I don't say who is correct, who is wrong, but you can make the system more stronger. If you know in the beginning, you can fix the things very easily rather than just after spoiling everything. But here also good works are going on, things are working well, but slowly we will come to that level. More people are getting training, understanding. Is it way of angle should be changed, positive, wherever possible. We can also spread that knowledge and your experience to other people. Will become more smart, will make other people also smart, right? Any questions? 5 minutes. Well,
Sir, how waste, grease, and mobile come into the economic generation?
what is that saying?
Waste, grease, and mobile.
Waste.
Waste, grease, and mobile that come from the industry. Waste,
Waste coming from the
grease, and oil
oil
also
and grease.
come into the economic generation.
Oh, economic value, they make a lot of fuel. What is oil and grease? See, that's a good question. It is slightly different, but I will tell you. When you extract a crude oil, that you tap that at a different stages. right from kerosene to gasoline, diesel, grease also one of the product for that. Then this they make a lot of grease products there. They remove oil from there and they use that the grease part to make some other products. That is how it has an economic value. So that is why they do. They also charge and they make a product out of this and that is used in the system. It has
But
a selling value.
sir, in restaurant or something, it very less quantity.
Less quantity,
Very less quantity. But that effect on the contamination, but it is very less quantity.
less quantity, but it is collected from different industry. There are different vendors. How it works is just like your solid waste management. Guys, collect the waste from different houses, collected at one place. When it is collected at one place, it is enormous. It is similar. You will find one in state, but however expensive, they have to make sure that that grease is collected. Imagine how many restaurants are there, how many commercial units are there, how many industries have an oil and grease issue. Oil and grease is removed, where it will go,
Yes, yes.
right? We have a very first treatment train is what? You put a screen, then next is what? Grit chamber, and we make sure that oil and grease is removed. Every treatment plant. And here is actually more oil and grease. I don't see a restaurant have that trap, right? That is a big. Every restaurant must have an grease trap, and people will come just like how they collect the garbage, they dispose it up, trucks together. So it has a lot of. It is not that it is producing less. I don't want to pay. I just want to throw in the. That is all. That is why the fines are so much. If you do anything like that, so everyone will follow. So this is how all industries, all treatment plant, they collect and do it at one place. Okay?
More question? Okay.
No questions? Thank you.
So thank you, Dr. Vijay Pakshat sir. In this way, we have completed 10 lectures of almost 13 to 14 hours duration. Thank you very much to Dr. Vijay sir. We are very inspired.
My pleasure. I was unable to
Throughout
teach
the
something.
industrial visit, he was with us. He has given a lot of knowledge to us. In second half, we have a small tutorial, and then we will do the certificate distribution process. Okay, thank you very much.